Following our lecture on correlation, we continue with a consideration of regression analysis. In this lecture, we'll look at regression analysis, which is a statistical method that is used to measure the influence of one or more independent variables on a dependent variable. It is also used to make predictions. We distinguish between simple linear regression, where we have one predictor, and multiple linear regression, where we have multiple predictors. We also look at logistic regression, which is used for categorical outcomes. The key concepts of dependent and independent variables will be defined, and we'll look at the use of dummy variables to incorporate categorical data into regression models. The overall goal of this introductory lecture is to understand how changes in predictors are associated with changes in outcome. For example, you might be interested in what influences a person's salary. In order to find out, you could take the highest level of education, the number of hours spent working in a week, and the age of the person. You could go on to investigate whether these three variables have any influence on the person's salary. And if that is so, you can then predict a person's salary by using the highest education level, the weekly working hours, and the age of a person. And this is what regression analysis is all about. In regression analysis, the dependent variable that is the variable that is to be inferred, while the independent variable is the variable or variables that we use for prediction, and we sometimes call this the predictors. Regression analysis pursues two goals. The first is to measure the influence of one or more variables on another variable, and the second is to predict a variable by one or more other variables. The regression analysis therefore provides us information about how the value of the dependent variable changes if one of the independent variables is changed. So, regression analysis can be used to measure the influence of one or more variables on another variable, and this is essentially what we're talking about. So examples are, perhaps we're looking at things that influence a child's ability to concentrate, and so we may ask questions as to whether the educational level of the parents, the place of residence, whether these things affect future educational attainment of children. We can predict a variable from one or other variables. An example of that would be, how long does a patient stay in the hospital? What product is a person most likely to buy from an online store? So these are examples of using regression to predict. What types of regression analysis are there? There are actually several types. We have simple linear regression, multiple linear regression, logistic regression, and this is but just a subset. This table does not show things like ordinal regression or Cox regression, and these are other types of regression. So for simple linear regression, you have one independent variable, and for multiple linear regression you have two or more. Similarly, for logistic regression we have two or more independent variables. And then the dependent variable for simple linear regression has to be a scale variable or a continuous variable, while for multiple linear regression it's also scale or continuous. In logistic regression, however, the outcome is categorical, and it's categorical binary. That is, it has two levels. The independent variable in any of these types of regression can be continuous, ordinal, or nominal. So the key distinction between the types of regression that we come across are, first of all, the number of independent variables and the type of dependent variable. So when it's a continuous variable or a scale variable, that is when we do linear regression, and when it's binary categorical, we do logistic regression. So Let us consider these examples. If we look at this question, does the weekly working time have an influence on the salary of workers? We see that in this case we're going to use simple linear regression. And why so? Because we have just one predictor variable, which is weekly working time. And so simple linear regression will be the tool of choice that we're going to use to seek to answer this question. In contrast, if we have a question that goes like this: do the weekly working time, academic degree, and age of employees have an influence on their salary? We would use multiple linear regression, because in this instance we have two or more independent or predictor variables, and these independent predictor variables are weekly working time, academic degree, and age of the employee. So we use multiple linear regression to see if these variables will influence their salary. If the question were framed like this: do the weekly working time, academic degree, and the age of employees have an influence on the probability of having at least one employee? Then it becomes a logistic regression. And why? Because the dependent variable is a categorical variable that has two levels, yes or no. The dependent variable in this case is having at least one employee. And so the answer to that is either going to be yes or no. Does he have at least one employee? Yes. No. So in this case we do a logistic regression, and this illustrates or emphasizes that key distinction between linear regression and logistic regression. In logistic regression, the dependent variable has two levels. It is categorical. Whereas in linear regression, the dependent variable is a continuous variable, or is measured on the scale as a scale variable. We also have what are called dummy variables. And these are independent variables with a categorical level of measurement. So they could either be ordinal or nominal. And so we need to recode these sort of variables as dummy variables for regression analysis. And this is one key pitfall that a lot of people or mistake that a lot of people make in analysis. So they take variables and just feed into the software and look at the output without having recoded the categorical variables as dummy variables. So how do we do this? So we create k new variables corresponding to each level of the categorical variable, where k is the number of categories. So if, for example, we have 4 levels, so let us consider like let's say educational level. So you have primary, non-primary, secondary, and tertiary. So that's 4 levels. So that means that in creating dummy variables, we're going to create 4 new variables, because our level of education has 4 levels. In the example that we see here on the slide, it looks at whether the person has a degree or not, or type of degree. And so this particular variable has 3 levels: no degree, bachelor, master. So each new variable is coded 0 or 1, corresponding to the presence or absence of the value for that observation. So for a particular observation with bachelor degree, the corresponding dummy variables would be no degree, bachelor 1, and master 0. So this is how we do dummy variable coding. We create new variables up to the number of levels of the particular categorical variable we're interested in, and for each new variable we assign a value of 0 or 1 depending on whether that particular observation has a corresponding value. And then we use k-1 variables in the regression analysis. The variable that is dropped is the reference level. You may ask, why don't we use all of the new variables? And the reason we don't do that is, if you put all the new variables into the model, then you are going to get the problem of what we call collinearity, and the model is going to be overfitted and problematic and give us wrong estimates.